Hey guys, Manake Senpai here. In this video, you'll learn the difference between rigid body and transform and how to move them. So let's get started. First, I'm working in 2D. If you are working in 3D, just the difference is rigid body 2D in code. You'll just write rigid body. Rest everything is same. Okay, cool. Right. Let's just create a 2D object sprite. Let's make its color blue so we can see it. Choose a circle and let's make it big. Cool. Let's just drag this camera in the sprite, and the sprite will be our player, and the camera is inside the sprite, so it will follow our player. So let's create a script. Player add component script. Let's just write player. Alright, and open it up. So main is to move an object inside Unity is to use rigid body and use transform. Let me explain the difference between transform and rigid body. How transform moves the player is it teleports the player from one point to another every frame. So it just like nudges forward slightly, so it appears us to be moving. Whereas the rigid body, it actually moves. It calculates every step and moves. So if I transform this to this position, it will just instantly teleport from here to here, but rigid body will move from here to here. So what this does is when it collides, let's say imagine this is a wall, when this object will collide, every update it will teleport slightly inside the wall, and then the collision detection will realize, oh, the object is inside the wall, so it will push it out, and next frame it will go in again and push out, in out. That's why it will cause some jitter. Whereas in rigid body, it won't cause jitter because it takes all the physics of collision in calculation. But since this is a rigid body and it takes all the physics calculation, it is processor heavy. I mean, if you're just using it for a player, it won't matter. But if you use it for like thousands and thousands of objects in the background, then it will be processor intensive. So the main rule is, if you are using collisions, then use rigid body. If you are not using collisions, then just use normal transform. Got it? Alright. How do you use rigid body and transform? Let's start with transform. So let's just delete the start function and look at this. This is update. What update does is that whatever code is written inside here will run every frame. Alright, so let's just write some simple code. So let's just write transform. So what it does is it is referencing this transform component here. Let's take the correct position. Whenever you put a dot, it goes inside the component. So inside transform there is position, rotation and scale. So we can write position, so it will show the position, or rotation or scale. Let's go for position. Alright, so currently we are getting transform.position, which is currently 0 0, but we can add something into this transform.position. So every update transform.position will be transform.position plus this new vector. Got it? First update will be x will be 4, then 8. This is most basic, easiest way to move a character. Right now we don't have any frame of reference, so I'll just import some sprite so you can see it in action. Let me just drag some sprite. We have our sprite. Let's make a new tile map. Alright, so this is just some random box. So when I hit play, it should move in the x direction. But because it's too fast, you didn't even see. So let's just make it slightly slower, or like 0.4. Right, so you should see it still moves super fast. 0.04. Right, you can see it moves easy, cool. Right, that's just very basic trash way of moving it. We want to move it using arrow keys. So input.get axis just takes your arrow keys. If right arrow is pressed, it will show 1. If no arrow is pressed, it will be 0, and if left arrow is pressed, it will get -1. Alright, so we want it to be stored in horizontal float, which I made up there, public float hor. Instead of using 0 here and here, I'll just put hor and var here. So this is just basic input. So instead of it being constantly increased by 0.04, it will be increased by this value of your input. There is a flaw though, but for now I'll just show you this. Don't use this in your system, okay? Currently Currently it's very fast, and it goes even faster in diagonal direction because of the way how two vectors add up. So to fix that, you just normalize it. So that vector, I'm just storing it in input to make it look neat. Let's just set speed equal to like something like 4, and this is compensation for frame rate, this is compensation for diagonal direction. You don't have to worry about all this, just copy paste that. But the main part is the position is added with input. Okay, cool. So it works now. You can move around even with joystick, which is cool. But what about when we add collisions? So let's just create an empty object, add component collider right here somewhere, duplicate it, put it here somewhere, duplicate it. Alright, now you have our colliders in place. So look what happens. Yeah, it just completely ignores them because we are teleporting. It doesn't check for collisions like that. So if this kind of script is better when you don't have collisions to account for. If we remove this component and add component called RigidBody 2D. I mean, if you're working in 3D, you use 3D and freeze rotation and no gravity. So gravity be 0, angular drag 0, is automatic. So who cares? Collision detection continues if you want precise collisions, but it is processor heavy. Now if we go to script, so first we need a reference to that rigid body. So public rigid body, I'll just name it RB. We get the rigid body component and drag our player into it. So now we can access this RB. Instead of doing this like transform.position, we can just do rb.add force input. So now you can see it works with the collision and there is no jitter. But the movement is not constant because you are using force, so it gradually increases in speed. If we don't want that, we can just use velocity instead. We write rb dot velocity equals to all this thing. Now one more thing to keep in mind. Rigid body is happening every physics step. It is good to put it in fixed update instead of update, and instead of using delta time, we will have to use fixed delta time. You don't have to worry about it, just copy paste this. So if we go inside Unity now and hit play, as you can see it's working, collisions are working, everything is fine. Now if you want to add a jump or anything, so you can use this, add force. If you want jump and if you want acceleration, you can use this. If you want constant speed, you will use this. But in our transform example, we had constant movement. So what if we want to add force in our transform position? Alright, so if you want to accelerate this, make new variable called acceleration and acceleration max. So let's set it to something like 100. So we can make a new if statement here. If some key is pressed down, acceleration increase the acceleration by 1 times that time dot delta time, just to compensate for frame rate. But it will keep on increasing if we just leave it at this. So we add another if statement that acceleration is smaller than equal to acceleration max, then only increase the acceleration, set the acceleration back to 0. So when it is not moving, then acceleration is 0. Simple. So now here when you are multiplying speed, you can multiply it with acceleration too. Go into Unity and hit play. You can see that it is accelerating too much. So let's just decrease the speed and acceleration a bit. So you can see it nicely accelerates, and you can see it still glitches out of collision walls because you are using transform position. Alright, nice, cool. So last thing is what if we want to move to a specific point? For let's just create an empty object, name it point, public game object move point. Go to Unity, go to the script and put the point here, add some script to our point. Let's just call it point and open it up. So we just want transform.position. When you left click, so input get mouse button down, get mouse button 0, which is left click. Transform position will be your mouse input position. This is just it converting from from axis to pixels. Just copy paste this code We can't directly modify this variable like that, and we don't want mouse position z position of our mouse. We just want x and y, so that's why we have to put it in some another variable. I just called it target position, you can call it whatever. And then lastly, transform the position equal to target position. Easy. Now in our player script, transform dot position vectors will move towards your original position, to your final position, and the speed. So if you go into Unity and click play, as you can see, it works. I click here, it goes there. I should just make it a bit faster. So where I click, it goes there. Now same with, let's do same in RigidBody. So here we will use rb.move position, and as you can see, it takes vector to position. We can't just put move point dot transform. Since this is a vector 2 and this is a vector 3, we have to convert it into vector 2. Now we can just go into Unity and hit play, and as you can see, it is working properly and the collisions are working too. We learned how to move an object using transform and RigidBody using mouse, keyboard and controller. So if you want to expand upon this idea and knowledge and you want to do something else, you can just refer the Unity documentation, not manual scripting API, and search transform, and you will find transform, and you can read all about it and all sorts of, like, this is transform dot position, transform dot rotation. Same with rigid body dot add force, and how everything works. You can just look everything up here. Thank you guys for watching. See you in the next one. Bye bye. You can request tutorials in comments.